All right. What we're going to take a look at here are called postulates and theorems, and we're going to learn a little bit more about points and lines and planes. So, now these postulates and theorems you should put into your little book, but we're not going to take time to do that now. You can do that on your own time when you're doing your homework. Now, it says through any 2 points there is exactly one line. Is this true? Okay. Now, I want you to think about this for a second. What would happen if I do this is my point, and I call that A. I got a point over here, and I call it B. Now, the next thing that I'm going to end up doing here, focus down just a little bit, I'm going to make a line. Okay. Now, I've got my line. Does that mean that if I do this, there's exactly 1 point between those lines, right? Okay. So does this mean if I draw one that goes through, I gotta move it a little bit. Is that another line through the same points? But how can that be if we've only got one line through a point or through 2 points? Something's wrong here, right? What do we know about a point? It names a location, but okay, so I got a location, so I got location A and I got location B. What else do we know about a point? It's something that it doesn't have. Of course it doesn't have a line, it's a point. Okay? No size. So when we think about a point, we actually have to think of it being very, 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 very small. Okay? Well, like I said before, close the Chromebooks. Watch up here and listen. Now, because it doesn't have any size, could a point be this big? If it has absolutely no size, can a point be that big? If a point is this size, can it actually be that big? No, because a point has no size. I'm just representing that, hey, A is over here someplace, and it's got a line that goes through it. So even though when we draw things out, we write things out, we identify points, we make them kind of on the bigger side, right? There is only one line that is going to go through them. There is never going to be the situation that I've got here. Not going to happen. So for this, in this case, that's got to disappear. Even if our points look like this, there is only one line that is going to go through them. Okay? So, Theorem 1.4. If two lines intersect, then they intersect at exactly 1 point. So, if we take a look at the ceiling again, okay, and we're dealing with all these nice little lines that they put up here. I'm glad they do that in the math classroom. Makes life easier for geometry. So, these lines go this way, right? I got lines that are going across. So if I take a look at this one here that's going all the way down, and this one here that comes all the way across, it intersects in how many places? It intersects in more than one. How can it intersect in more than one? If this line is going this way, that line goes that way, and they hit right there. Okay, you mean something like this? But my question is a curve a line? But a line is a connection of points that go straight. What would we actually call the thing that we see there? That's actually a curve, isn't it? So because this here is a curve, granted it goes through B and A, it isn't a line. A line is something that is absolutely straight. Okay? A curve is something that, well, curves. Okay? So just because you see something like that doesn't mean that it's going to work. They're two different types of objects. So let's try this one. It says, through any three non-collinear points, there exists one plane. Okay? We've talked about the idea of a tripod, haven't we? It's part of the reason why a tripod is the way a tripod is. If you've got 3 points and you put it down, you can put it pretty much on any surface, right? If you're out camping, or better yet, grilling, you've seen those big black kettle grills, you know, that you put the charcoal in. They usually have wheels on them, right? There's 2 wheels and then a leg that's out front, correct? 3 points. So it can be on ground that is somewhat uneven and still be stable. Does that make sense? That's why we have to have it that way. And any 3 points represent any 3 points represent a plane, correct? Any 3 points represent plane. Any 3 points, right? What is the one word that you must make sure that you have? Non-collinear. If I had all 3 of those points on one line, do I have a plane? I don't have a single plane. You got to kind of think of it this way. If I look at my cabinet doors back there, and if I said that the hinges are going to be points on the plane, okay, those 3 points. I have a point there, point there, point there, point there. All these hinges work together for this plane, right? Look at the doors, the plane. I have the plane coming this way, I have the plane coming that way, I have the plane going this way. I have the plane just back here closed, right? But if I have one of these hinges pushed further back there, or pushed further back here, would it work that way? No, I put the door that put it so that door kind of goes in any direction that I want because all 3 of those points are in line. They're collinear. So that is the reason why we get that. So we got to make sure that we state that it is non-collinear. Okay? Non-collinear. Now, the next thing that it's got here, theorem 4.2. If there is a line and a point not on the line, then exactly one plane contains them. Well, since we can put any 2 points we want on a line, right? And if I got a 3rd point, that works. Now I got a question for you. Is this a plane? Could I consider that screen that I just rolled on a plane? It's a flat surface, right? We're going to consider it a plane. Is that a line up there? Now, this goes anywhere my hand pulls it, right? If I pull my hand out over here, do I still have a plane? Is it still straight up there? Yeah. But my hand being the point designates where this thing goes. It goes here, or it goes out here, or it can sit back in here, right? This, it goes back. But it doesn't matter. That's a line up there. I can have it pulled back and this way, wherever my hand was at, or I can just have it hanging straight on. I've got a plane. But that handle determined where it was going to be. Okay? So, if 2 lines intersect, then there exists exactly one plane that contains them. Look back at the ceiling again. If I take a look at the lines that are going across the room and the lines that are going the lengthwise of the room, so the line's going this way and the line's going that way. They only meet on the ceiling. That makes sense, right? What about this one right here? I got one metal piece that goes all the way back there and comes all the way over here. If I go and use this corner over here, this line between these two planes, does that mean those two lines are on the ceiling? Where are those lines? On the wall, because that's the only place, the only plane where both those lines would be found. So when you're talking about these things, you got to kind of have a picture in your mind as to what they're going to look like. So let's try this. Bigger. So what happens if I want to name 4 points on here? Are there 4 points on there? What are the 4 points? A, B, C, D. Well, that's nice. That works well, right? How many lines do I have? Which are A, B, and C, D. How many planes do I got? 2. Which planes? M and N. Okay. Easy stuff. I got to find something more difficult for you guys. Okay. Now, postulate 7. It says if 2 planes intersect, then their intersection is a line. Well, when I had the screen pulled down, was this screen intersecting with the ceiling? And what is that? That's a line, right? What did we say where we have the floor and the wall over there intersecting? What does that form going across it? A line. Front wall and side walls? Lines, you got a corner there. Way too easy, right? I like it. So let's try this. Okay. So, where do planes M and M intersect? Make it a little bigger if you like. Where do they intersect? Line GH, could I say line GP? Well, why not? P's right there and G's right there. They're on the same line, right? Huh? They're not? I mean, I got this coming right through there. It looks like I got G, I got P, I got Q, and I got H. Are all 4 of those points on the same line? So I could call it GP, I could call it GQ, I could call it HQ, right? Or HG, or HP. I could call it just about anything I want except late for dinner. Okay? So, any points that are on the line are fair game to be used to identify that. All right. So, a couple more postulates here. Postulate 8. If 2 points lie on a plane, then the line containing the points lies in a plane. That makes sense. 2 points lie on a plane. Could I call my desks points? Okay, they're points. They represent certain places on the floor, right? So, if I got 2 points, or 2 desks, and I wanted to make a line of desks, would those 2 desks be part of it? Would they be on the floor? Or would I want to stack the desks on top of each other? Might be a little challenging to do, but that really wouldn't give you a line, would it? You'd have some up here, some down there. But I've got these desks in a line here, don't I? So if I take the desk that's up over here, the desk that's way back there, I got desks that are in a line. They're all on the floor, right? So that works. Now, postulate 9. A line containing at least 2 points. Okay? Line contains at least 2 points. A plane contains at least 3 non-collinear points. And space contains at least 4 non-coplanar points. So, if I want to represent this room as space, now you got to remember, you guys take up space, right? If I want the space of this room, do I have to figure out what the length is, what the width is, and what the height is? Sure, I need to know those 3 things. Could I define a space in this room by point A over here, by point B over there, by point C up there, and point D over there? Would that represent space? Yeah, because it says space contains at least 4 non-coplanar points. I got A, B, and D. Are they on one plane? They're on that wall, right? Because I got one on that whiteboard, one on that whiteboard, another one on the whiteboard back there. Then I've got one on this whiteboard over here, that's C. Okay? I have 4 points, not on the same plane. I've got space. Okay? Kind of helpful, right? So, let's see what else we got here. Let's see. So let's talk about A, B, and C. So if I look at A, is it possible to draw another plane that has points A, B, and C, those exact same points? Can I draw another plane that would do that? Contain those points. How? Yeah, yep, okay, fine. No, I'm not finding anything. I want to go and identify a plane like this desk, and this desk.
All volleyball girls are now excused.
So all girl volleyballs can go. But you're human. Not volleyballs. Anyhow, so if I got these 3 desks, do they identify the plane that's my floor? Because they're all sitting on it, right? It's not like the desks are on the ceiling, right? That wouldn't quite work so well. So, if I have those 3 desks as they're sitting in the room, can I go and have them make another plane? No, because they're just on this floor. A, B, and C are on that plane. They are not going to go anywhere. Okay? That is all it can be. What about B? If I identify a line in plane M, what is the intersection of C, D, and AB? Okay? What's that intersection? There we go. Oh, what? Oh, point O. Oh, I thought maybe you were going, oh. Oh, ah. So point O is the intersection of those 2 lines, right? Okay, that's easy enough. Okay, so when we get to C here, we kind of talked about this a little bit there. Camping supplies are made with 3 legs. Chairs, small tables often have 3 legs. Why would that be? Balance. So that, well, yeah, balance, I mean that they're stable. But now they're asking this question. Use postulates to explain their reasoning. Well, we know that if they have 3 legs, they're going to be stable sitting on the ground, because even if it's uneven ground, it'll be stable, right? And the reason that that is going to be the case is because of this postulate way up here, postulate 6. Through any 3 non-collinear points, there exists one plane. I mean, if you think about it, you got that nice big Weber grill. If all three of the legs were in a line, would it stand up? No, wouldn't work very well, would it? So,